In this video, we're going to learn about the second of three main forms of quadratic functions. In section 4.2, we're going to learn about standard form. So to start, let's talk about what the general rule for standard form is. Standard form of a quadratic equation looks like this. F of x equals ax squared plus bx plus c. One way to easily be able to distinguish this is by looking at the fact that there's no parentheses, everything is multiplied out, and all of your like terms are combined. Key features of standard form goes as follows. Our a value is going to be the leading coefficient with x squared. So our a value we can see right here. Whatever number comes in front of the x squared is going to be your a value. Next is your axis of symmetry. Now, since we can't necessarily see what our vertex is, unlike vertex form, what we're going to have to do to find our axis of symmetry is we're going to have to calculate negative b, so our b value, over 2a. Whatever value that produces will be our axis of symmetry, and more importantly, it'll also be the x-coordinate for our vertex. Finally, last but not least, something unique to standard form is it tells us what our y-intercept is. Our y-intercept, or where this function crosses the y-axis, will be whatever our c value is. So if you want to find your y-intercept for a quadratic function, and it's in standard form, the coordinate would be 0, comma, your c value. So let's use what we just talked about to be able to find, or be able to graph an equation in standard form. So here we have the equation y equals x squared plus 2x plus 3. So something that we're going to want to do right out the gate is figure out what our a, b, and c values are, because that's ultimately what's going to help us graph it. So my a value is going to be my leading coefficient for x squared, which is 1. My b value comes in front of the x, which here is 2. And my c value is 3. So before I do anything, again, what's unique to our function in standard form is that seeing this 3 means that if I plot a coordinate at 0, 3, that's going to be my y-intercept. From here, let's find the axis of symmetry, and that's going to help us 1, 2, 3. And that's going to help us find the vertex, which is ultimately going to be the most important in terms of graphing this. Our axis of symmetry is negative b over 2a. So in this case, is going to be negative 2 over 2 times 1, negative 2 over 2, which is going to be negative 1. So I know that my x-coordinate of my vertex is negative 1, and I know that my axis of symmetry is going to go here. So let's use this axis of symmetry. I know that my x-coordinate's at negative 1, but I need to know where my y value is. How I'm going to do that is I'm going to plug this in to my equation. If I plug in my input as negative 1, it's going to spit out my y value, or where my y value is in the vertex. So here I'm going to do y equals negative 1 squared plus 2 times negative 1 plus 3. If you're doing this in the calculator, make sure to put your negatives in parentheses, especially like for this term right here. If you don't put it in parentheses, it's going to spit out the wrong value. Here I know negative 1 times negative 1 is going to give me positive 1. This is going to come out to be negative 2 plus 3. So my y value here is 2. So my vertex is negative 1, comma 2. Go to negative 1, 2. And then already, just judging by my 2 points, this is going to make sense since my a value is 1. Going from the vertex to the next coordinate is 1 over 1. And I'll make my parabola from here. So last but not least, what we're going to do in this video is take a function that's in standard form and convert it to vertex form. So here we have the equation y equals 2x squared plus 10x plus 7, and we want to get it to vertex form. So right out the gate, let's just put my a value, b value, and c value. A here is 2, b is 10, c is 7. If I want to get an equation in vertex form, my goal is going to be to get it to look like this. The key features of what I need is I need my vertex, and I also need my a value. I see that my a value is 2, so I already got that down. So now let's do some math and let's find out what our vertex is. To find my vertex, I'm going to start by doing negative b over 2a, which is going to be negative 10 over 2 times 2, which is going to be negative 10 over 4, which as a decimal is going to be negative 2.5. So that's the x value of my vertex coordinate. To find my y value, I'm going to plug it into the equation. Y equals 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. I would spit this whole thing into your calculator. Again, just make sure, especially for terms like this, if you're taking a negative to a power, make sure that it's in parentheses. If you do all that correctly, you should get negative 5.5 as your result. So from here, all I'm going to have to do is plug this into my equation. Y equals 2. X minus negative 2.5 is going to change to positive 2.5 squared minus 5.5, and I'm done.